Hello, everybody. My name is Benny Sudakov. As was said, I am professor of mathematics in ETH Zurich. And actually, listening to Munyong, I also travel and kind of change a lot of lands and places. And let me start by saying what got me into mathematics. So my family was mathematically oriented. So my father has himself PhD in applied probability. So obviously, as a kid, I grew up with playing with various puzzles and doing exercises. But what's really nice, what happened to me in the middle school. So in the middle school, I had a teacher who observed that, I'm bored with the usual exercises. And when I studied in Tbilisi, so I should say that I grew up in Georgia when it was still part of the Soviet Union. So Soviet system, educational system was pretty robust, and in particular, nice thing was that every school book, so for example, I liked a lot geometry, so the school books were written by famous mathematician himself called Mogorov. They had, in addition to standard curriculum, in the back of the book, they had a list of problems of extra difficulty. So it was already expected that if the kids would be bored, so the teacher can use this problem. And indeed, my teacher did it, and I played with them, and I succeeded to solve. Most of them I got interested in the subject. And then another event which will happen was that somebody, so again, it's in Soviet times, there was a special journal for school mathematics called Quantum. And I didn't know about it, but my father, I don't know, through some friends, brought one issue, and this issue had questions. And I was really surprised that I thought myself, I know already how to solve all the geometry questions, but it was a question which was very innocently sounding, which I couldn't solve. I try, and I said, okay, I want to be able to solve such questions. So I look around. So in Tbilisi, there was a special school in math and physics, which you can apply, and I applied there, and I started my high school in this special school. So then in the special school, I met another bunch of very exciting people. So in particular, there were some people who were already well-established scientists who were working in the Institute of Mathematics in Tbilisi, who would come and talk to us kids about mathematics. They mostly were preparing us for Olympiads, but being mathematicians themselves, it was very interesting. They were also telling us about how the real mathematics is operating. And in particular, in high school, you start learning calculus, and you start learning it on very intuitive level, which was a bit unsatisfactory to me. So one of the guys suggested me that I would take the book, in real university book, called Baby Rudin, and I will read it and try to understand the problems really deeply, right? The nice thing about Baby Rudin is that you have, for almost any phenomenon, you have lots of questions about creating counterexamples, right? You think about phenomena that you understand it, and then you suddenly realize that you not quite understand it, that if you miss one or two conditions here and there, you get a counterexample to the statement which you thought is true. And actually, this is a really cool thing about mathematics, right? That you need to understand certain things really deeply, so you can try and play with them. You change a little bit the condition, and suddenly you get to another problem, which the answer is very, very different, right? It's like you're trying to uncover how the world is built, like which building blocks are necessary to create a certain structure. So that was what I was interested in me in mathematics. But actually, my career pattern was not a very straightforward. So after Soviet Union collapsed, I moved to Israel, where I did all my education. And in particular there, at some point, I was not quite sure if I want to continue with math. So when I started my PhD, I in parallel did 1 year of MBA program. So I studied economics and accounting. And then after this year, I realized that actually I enjoy this MBA program. It's very interesting courses. But what I enjoyed the most was the most mathematical courses in the program. So I get a second thought, and I realized I better stick with my PhD and continue doing math. So there's another interesting thing which you indeed, following some of the speakers, so you can easily change the topic. So actually, when I was studying in Tbilisi, so I started with topology. So because I already know a little bit basic math, which was studying, was teaching in the first few years, so again, people in the Institute of Mathematics were very happy to talk. And in Tbilisi, we had a lot of former students of Sergei Novikov, and so they were all topologists, so I started to read a lot of topology. I really enjoyed. But then when I moved to Israel, I somehow discovered discrete mathematics. So my advisor, Noga Alon, was giving a very interesting course about using tools from probability to prove combinatorial statement. And this was really, I don't know, very inspiring. You suddenly see that one subject, which has nothing to do with the problem at hand, can be used to solve the question. So I really, really got excited. So I moved from topology doing discrete mathematics, and that's what I'm doing today. So now, I mean, I don't remember all the questions I need to address, but I think one of the things was to what kind of advice I can give to people. So one advice, especially since lots of people maybe here come from Olympiad, one advice which I want to give you, and it's actually, I wish I would maybe thought about it when I was younger, is that take the mathematical journey on your own pace. Don't look around, don't see who is faster, who is slower. You know, when I was already quite grown up, I read a really cool book. I totally recommend you to read. It's a book by a famous Japanese writer, Haruki Murakami. It's called What I'm Talking When I'm Talking About Running. Now you would think why he wrote this book. Also, he was a very famous writer. And in this book, he tells his personal story, where he's, in addition to being a writer, he likes a lot running marathons. And one of the parallels which he draws, which I think is very relevant to scientists as well, and actually for almost any person, the life is really not a sprint. So you don't really need to be discouraged if you try something for 1 or 2 weeks and it didn't work, right? So life and also your journey in mathematics or in any science you'll take, it's like marathon. So it's really very important what will happen after 40 kilometers. And I really remember this picture which he describes in his book. He says, you come in the morning, you take a piece of paper, you have an idea for the book, you try to start writing, and the first sentence doesn't come. And then he says, and after a while, first he was frightened, and after a while he realized that you need to sit and continue thinking, and then eventually the first sentence comes, and the second sentence comes, and you will write the book. And the same thing I think you need to know when you're dealing with the mathematical questions. So you come, you think a little bit. The most important thing, you really need to like the question at hand, right? So if you like the question at hand, then take your time. Exactly like Munyon said, you don't solve it today, you come to it in a year, you come to it in 2 years. Eventually, because if you have the persistence, you will solve it. And I think this is the most important advice I can give you. If you go to any kind of scientific project, not only to math, take your time, come back to the problems you like, and if you're not afraid to spend your time, you will eventually solve them. So that's what I wanted to say.